Hello, and welcome to this webinar from the Zhaga Consortium. My name is Tim Whitaker, and I am Zhaga's Marketing Communications Director. After a short introduction, I will hand over to our two presenters, who are Martin Croyson from Philips Lighting and Jonathan Catchpole from TE Connectivity. On the screen now, you can see the agenda for today's presentation. Martin is going to talk about the need for upgradable intelligent luminaires. Then Jonathan will talk about the new connector proposal. And then Martin will resume with a discussion of system architecture, after which we will have the next steps and then a Q&A session. The presentation materials will be sent to all participants shortly after the event. We welcome any questions you may have, so attendees are very welcome to type questions into the Q&A section on your screen, and we will read out the questions and answer as many as possible during the Q&A session at the end of the presentations. If you have any issues with the presentation itself, if you want to discuss with the webmaster, then please enter your question into the chat section. To enable an open discussion, all questions will be anonymous. You will not be able to see who's asked a question. We will not state the name of the people asking particular questions. So I'm going to briefly introduce Zhaga. As you're probably aware, Zhaga is a lighting industry consortium with over 100 member companies, and we are standardizing LED light engines and components. We are creating a set of interface specifications known as books, which define the conditions necessary for interchangeability. And the purpose of the webinar today is that we have a new proposal, and this is slightly different from our existing proposals. In fact, it's a specification for the interface between a sensor communication module and an outdoor luminaire. So if I can just briefly summarize how we normally create proposals. Within Zhaga, the Zhaga members submit proposals for discussion, and there is typically a phase where we reach a consensus so that we end up with a single proposal, which is then developed further and turns into a specification. And at some point, that specification is published and then is available to everyone in the industry. What we're doing in the webinar today, which is a unique step as far as Zhaga is concerned, is that we're making the information public about the proposal so that we can get input both from members and from non-members to make sure that the specification is heading in the right direction. So, with that introduction, I'm going to hand over to Martin Croyson from Philips Lighting, and here we go.
Okay, thanks Tim for this introduction. Indeed, I will start discussing the need for upgradable intelligent luminaires. I will also briefly touch upon the existing standards for connectors. Okay, on the first slide, there is explained the useful life of an outdoor luminaire, which in this example is 20 years, which is also a typical lifetime of an outdoor luminaire. This also means that when an outdoor luminaire is not installed with the option to upgrade this luminaire from a not connected to a smart luminaire, then we will lose this option and this node for the same period of time, so that means 20 years. So for us, it is a basic proposition that we have at least a system-ready proposition installed for every outdoor luminaire. So in this example, you will see that there is no connectivity at the start of the installation. But then in the course of 1 to 5 years, we will do the installation and we will add a connectivity or controls module. And then the rest of the lifetime, the module will be a smart node in the network. So for us, this would be a minimum system-ready proposition. Option 2 is that we will have already the connectivity controls module installed from the beginning. So in this example, you can see that the module is already installed on the Outdoor Luminaire. But and this is done with typically a Gen 1 connectivity module. When you would like to upgrade with, for example, a Gen 2 technology, you are able to do that, for example, in the course of the 1 to 10 years to follow. And then in the same node, we will have the updated and upgraded functionality for the rest of the useful life. The advantage of such a smart or system-ready approach is that we decouple also the useful life of the connectivity control functions with the rest of the electronics, which could be significantly different. This is of course not new, so upgradable luminaires do already exist, and as most of you maybe are already aware of the so-called NEMA standard, which is shown on this slide. This NEMA connector is available in different flavors, from 5 to 7 pins, even a 3-pin version is available. The major item is that it is a mains compatible node, which has quite some implications for the connector. And typically it has either a 0 to 10 volt functionality or a DALI controls functionality. And as indicated, it is designed to install controls either from the beginning or upgrade in the field. From the picture, it's also clear that it is quite a big node. Typically, the cutout in the luminaire is 35 millimeters, and also the related module is quite substantial. Another disadvantage is that not all the pins are clearly assigned in this standard. So, especially for the 7 pins, not all pins have a clear pin assignment, which is something what we would like to define in the new upcoming Zhaga standard. Another item is that this NEMA standard has typically only an on-top functionality. So when you would like to use this from a side or maybe even from bottom functions, then this is at this moment not provided. So this is a missing opportunity which we would also like to address in the new proposal. Before going to the introduction of the new proposal, we would like to also show some trends in luminaires because they are directly related to the need for this new standard. The first one is about the LED technology, which has been introduced already for some time, and which enables at the same time miniaturization of luminaires because of the intrinsic advantages of LED technology, and thereby also new form factors. So this also requires that nodes and smart modules should be less bulky. Another upcoming trend is of course the Internet of Things, which will drive new systems and services, and thereby also new functions related to connectivity and sensors. And what is present in the field at the moment are many different proprietary and non-proprietary solutions, which makes it at this moment difficult to select only one solution in the field, and makes it very likely that changes will happen in the next few years, and makes the need for connector and so flexibility in the concept required. Third one is of course commoditization of LED luminaires and related price erosion. Also this requires that the connectivity technology which we will choose is also price effective and not introducing a lot of extra costs, because this will hamper the introduction and also the need for connectivity and smart nodes, and this will hamper this. And so also there, cost effectivity is key. So I think this is now also the bridge which we would like to make to the new proposal, which will be introduced by Jonathan Catchpole from TE Connectivity. So I will now hand over to Jonathan.
Thank you, Martin. So as Tim and Martin have already alluded, through Zhaga, we are going to specify a new interconnection standard between a street lighting luminaire and a module containing sensors, antennas, or any other intelligence that you might require to put in. On the screen you can see at the moment is a concept. It is just at the concept stage at the moment, but we are looking to provide a specified part that will fit through a 20 to 22 millimeter plain hole in the bulkhead, requiring only a 30 millimeter flat around the aperture, and we're using that for sealing. You can see on the screen this threaded part of the receptacle, and that means that we can allow bulkhead thicknesses from 1.5 to 6.7 millimeters, and possibly removing any tolerance issues that you might have with the thickness of the luminaire. The design at the moment is looking like it will be significantly smaller than the 35 millimeters, and the height above the luminaire will also be smaller than 10 millimeters. So as Martin has said already, this will be significantly smaller than the ANSI NEMA receptacle. And we think with that smaller footprint that it will allow you, the designers, greater flexibility with the luminaires, greater profile surfaces, or just a lower profile luminaire. It will be a 4-position connector, and Martin will explain this later on in the presentation, but we will have a DC voltage going into the module, and then the control protocol will be a DALI with the DALI plus and DALI minus connection, and then a logic signal input as well. As you can see here, we have a separate anti-rotational feature. This is because of the plain hole in the luminaire, but I think that gives greater flexibility to allow these components to be designed in different ways to meet the requirements of the luminaire. So what are we proposing to specify through Zhaga? So on the slide here, you can see an example of the concept for a module and of a receptacle. For the mechanical interface, we will be specifying these bayonet and keying features that mate onto the receptacle. We will be defining this gasket area, not the size and the shape, but just the area on the receptacle and then on the module itself. And the module contact dimensions. So here we show the contacts. We will be fully defining their size and shape. And then on the receptacle, the contact interface. So basically these apertures that are shown here. On the electrical interface, as I said before, there will be 4 poles, and the poles will be assigned through the specifications. So we will have we will have the DC plus, and then the DALI plus, and the DALI minus, and the LSI defined. Voltage ratings. So we're specifying a 24 volt DC typical into the module with a 30 volt DC max. And the current rating will be 500 milliamps. Included in the specification will be a reference to DALI 2.0, but the protocol here will be a non-standard DALI protocol that will be available through Philips. Importantly, what we won't be specifying is the interface and sealing to the luminaire, the wiring connection to the receptacle, so we won't be defining the length of the wire or the cross sections, and also the receptacle contact details. So I said that we'd be defining the module contact details fully, but the receptacle contacts themselves won't be included in the specification. Also, the anti-rotational feature is not included, and the module housing or base, its size and shape outside of the interface won't be included in the specification. We do believe that this specification will give benefits. And then on this slide, we can see this example of what the receptacle could be. This is just an example, and the item itself won't be defined through Zhaga. But you can see the advantages here. We've got an integrated seal with no loose components for an operator or an installer to work with. The seals will be tested, will be designed to meet IP66 and then tested to meet the requirement, but also tested to IP65 as well. The module can be fitted with a simple insert and twist to mate and lock via this bayonet receptacle feature here. So no tools will be needed. The module can be fitted with one hand, and it literally can be fitted in a few seconds, and without having to electrically isolate the pole or without the use of skilled labour. It will be fully polarized through the bayonet features and the keying features. And this concept here shows that we won't be supplying with flying leads, so allowing for flexible placement of the receptacle on the luminaire and possibly reducing logistics issues with different wire lengths in the manufacturing. Contacts will be rated to 1.5 amps and 30 volts, although through Zhaga we will specify a maximum 12 watts into the module. And we'll be interested to hear your feedback on whether you feel that 12 watts is enough to power whatever intelligence you wish to put into a module. Moving on to the module itself. Like I said earlier, we will only be defining the interface area through the Zhaga specification, but here just shows some examples, some possible examples of modules. So with this design here, it's relatively small, about the same size as the receptacle itself. Possibly you can just house a photo cell into there. But the concept is designed to be fully scalable, so larger modules can be produced with more intelligence in there, with communications and with antennas fitted. The design will allow for sealing between a base between a base and the housing. We're proposing designs with a simple O-ring to allow for the IP66. And there also will be a sealing cap available. The sealing cap means that you can transport luminaires to site without the intelligence fitted, or you can install luminaires with no intelligence to start with and then upgrade at a later date. As Martin said earlier in the presentation, we feel that this gives a lot more flexibility. The NEMA receptacle is only really designed to be mounted facing upwards. So this receptacle can be used in the same way. So here we can see a receptacle and there with a module fitted. So for components that need to be upwards facing, like antennas, like the light sensor. But it's also flexible enough that it can be downwards facing, still providing the IP66, and modules can be fitted that contain occupancy or cameras, etc. And because of its compact size, we also feel that it could be used on a sideways facing for light passes, for example. And with that, I will pass back over to Martin to explain the system architecture of the overall system.
Okay, thanks, Jonathan. Yes, we are now going to touch upon the system architecture part. Now, the key component of this system-ready architecture will be the system-ready driver. Shown in this slide is at the left side the today's situation of a smart luminaire, which has a lot of additional components to make the luminaire and the fixture connected. In tomorrow's architecture, we will reduce cost and complexity by only having this SR driver in combination with the connectivity module and a standardized interface between the driver and this module. So that will ease the design-in complexity for the luminaire OEMs. One of the reasons that there is a lot of complexity is also that mains functionality is now going to both the driver and the connectivity module, which means that there are also a lot of functionality double in the system, which also induces extra cost. So what we are targeting for in this SR driver concept is to have a standardized open digital interface. There is also integrated a double low voltage power supply to power sensors and also control functionality. Integrated in the driver is also the power metering function, and there is the option to read out diagnostics. On the next slide, again, the modular approach of this SR architecture is clear. At the left side, you can see the different functions of the driver. So we have only one mains connection coming in, and also a standardized interface between the lighting controller and the driver, and then also the output stage towards the LEDs is clarified. At the right side, you can see the other important stakeholders of the system, which are the network partners, because they will take care of the dashboards, so they can develop the energy and maintenance dashboards. They will also do the asset management, maintenance planning, but also commissioning and configuration can be done remotely via this partner gateway. So this makes clear that there is a clear split of responsibility between the network partners at the one hand side, and the other side we have the luminaire OEMs, which have now an easy design-in option with this SR driver concept, and the partner lighter controllers that can also be provided by different players. Also, that will enable a new ecosystem around this SR interface. In this slide, you will see at the left side the current situation where we have typically a DALI driver and a central management system controller. What is key is that the mains is going into both the DALI driver and the CMS controller. So that means that also the CMS controller needs to take care that there is surge protection, but also the low voltage conversion needs to be done inside the CMS controller, which means that we have this function double both in the controller and the DALI driver. At this moment, the energy metering is done in the controller, and the dimming commands come from the controller towards the DALI driver. At the right-hand side, you can see the proposed SR interface, which is based on DALI 2.0. The energy metering with 1% accuracy plus the diagnostics is inside the driver. And there is a power supply, a low voltage power supply going from the driver towards the CMS controller. Again, the dimming commands are going from the controller towards the driver, and diagnostics can go the other way from the driver to the controller. But there is only one single mains entrance, and there is no mains requirement in the interface, in the SR interface required, which makes the connector design more easy. To summarize the benefits, so there is no need for an additional power box, power conversion, so that's handled by the SR driver. We have one universal mains controller, and also surge protection is done by the driver. The energy metering components can be eliminated from the controller, and also the overall luminaire integration is simplified. There will be less wiring and components required. So instead of a relay, we have now the full dim to off functionality. and also the LED driver diagnostics will be available via the driver. Now on this slide we have a similar overview, but now we see the position of the socket, because that is the main part of this webinar. So we have this 4-pin socket which has the following pin assignment. We have a 24-volt typical voltage going from the driver towards the light control unit. We have a double DALI interface, and then we have an LSI pin. That's at the left side for the luminaire OEMs. At the right side, we can see the benefits for the network partners. So we have a significant cost down towards the current NEMA socket because of the inherent low voltage concept. We have also no pins required no mains pins required in this interface, and we have an open standard, which means that there will be multiple suppliers for the light and control unit. The system itself is agnostic to the OEM and network choice. It makes it easy to upgrade the luminaires and also easy to integrate. The last slide is there we want to show the SR output box, because also in case you would have a more simple, cost-effective outdoor driver, for example, I want to 10-volt outdoor driver, it's still possible to hook up this type of drivers towards this SR architecture by using a so-called SR box. So the SR box has the same functionality. It has a full SR functionality, which means that it has a 24-volt power supply output, it has the DALI power supply on board, also the 1% power metering accuracy, and the diagnostics. And in this example, the 1 to 10 volt is clearly linked between the standard driver and the SR box. So also with existing driver functionalities, you are able to hook up to this SR architecture. You don't need to use the DALI concept. And with this, I would like to hand over again to Tim, because this was my last slide. And one moment.
Thank you very much, both Martin and John, for those presentations. We will shortly have a Q&A, and if you have any questions, please type those into the Q&A box right now. Just before that, I'm going to run through a couple of points to do with the next steps. As I said at the start, the main purpose of this webinar is to share the information for the specification proposal and to request feedback from the industry. So in order to do that, we would like to request you to complete the questionnaire that we will send out to all participants by email within the next few days. And your feedback is very important. Beyond that, to have a direct influence on the specification, its content, what the specification will actually cover, those issues will be decided at the upcoming face-to-face Zhaga meetings. The next one is actually next week in Shanghai, followed quickly by one in April in the Netherlands, and then one in June in Malaysia. So this will move quite quickly. Over the course of those 3 meetings, the specification will probably move forward to almost a final stage, I expect. So if you do want to have an influence, then please get involved. But to attend those meetings, you would need to look into Zhaga membership, and the information on the membership is found on our website, the URL there at the bottom. So we will now move to a Q&A session. You can still continue to type any questions you have, but to start with, I'll ask this question. The presentation mentioned a DALI 2.0 based SR interface specification. How can people get access to this specification?
Okay, so that will be available through Philips. So I'll let Martin answer that question.
Yeah, so this interface, SR interface, as also indicated in the presentation, will be based on the DALI 2.0 interface, and that's it. So it is an open interface, and that's also the advantage of choosing a DALI standard interface.
So where can people find more information about that?
Yeah, of course we have the DALI consortium. If people are not able to get the information, of course they can always get to the Philips representatives. If they have direct questions, we are always there to answer them.
Okay, so just on that point, I should add that when we send around the email with the questionnaire, we will also include the email addresses of the two speakers, so you can ask any further questions directly via email at a later date. The next question, why does there have to be a separation between the CMS controller and the SR driver? Why can the functionality not be included in one device?
Again, Martin, I believe that's a question for you.
Yeah, so what has been shown also in the presentation, you can see that the field of the CMS controller and also the technologies is very dynamic. There is a lot of different standards evolving and popping up. Can also be regionally different. So it's not wise to have that integrated into the SR driver, but I think that's a strong point of to have this SR socket so that you're able to even switch and also make the change independent or the choice for the CMS technology independent of the SR driver technology.
Okay. Next question. If I've understood correctly, there is no AC power going into the module. If that is correct, how are you proposing to perform energy monitoring?
Yes, you are correct. So there is no AC power going up into the module, and the SR driver, I believe, Martin, and correct me, has the energy monitoring feature built into that driver. So there will be no need to take AC up into the module and do the monitoring in that part of the system.
Yeah, Jonathan, that's certainly correct. So the driver will do the energy metering with this 1% accuracy, but also the SR box, as shown in the presentation, will have the same functionality. So also backwards compatibility with existing drivers will guarantee the same power metering functionality.
Okay, thank you. Next question, which I think may be a little difficult to answer, but I'll ask it anyway. What are the price differences between an SR driver and a non-SR driver?
Again, Martin, a question for you. Do you have any comments on that?
Yeah, so of course direct price information will not be shared during the webinar, but of course hopefully from the presentation it's clear that the overall system cost will be reduced because we reuse the functionality, not the functionality, but we reuse the double functions in the system architecture, like the search function, but also some low voltage conversions are removed. So the overall cost of the system will go down. And I think there's only a small price adding compared to the DALI existing drivers. But overall, the integration will be more easy and therefore also more cost effective. Okay.
So the presentation covered a lot of different aspects of technology, of system architecture, etc. But can you clarify which parts are actually likely to be included in the Zhaga specification and which parts will not?
So I believe that's a question for myself, and I'll just refer back to one of the slides. So this is what is going to be this is what's going to be included in the specification. So, like I said before, the interface. So this area of the module, including the keying and the bayonet features, the contacts for the module, and then on the receptacle itself, the apertures for the connection, and then the sealing area for the sealing between the module and the receptacle. That will be defined on both the module and on the receptacle. Not the size and shape, but just the area that it needs to be in. We are also we're also defining the number of poles, pole assignment, the voltage rating, and then the control interface. I hope that clarifies the question.
Yes, I think so. Okay, next one. What's the approximate timing for standardization within Zhaga of the connector? Is this the same timeline for commercial availability?
Yeah, so I think this is a question for me. So as indicated by Tim on this slide, maybe you can show this slide, but there will be 3 very soon Zhaga meetings. The next one is already next week, and there will be one in April and in June. The expectation is that certainly in this before June we will have the draft specification available. So then before the end of the year we will have also the book published for the people who are not member of Zhaga. But when you are of course member of Zhaga, you are able to join these meetings and also participate and contribute to the making of the specification. And there was a second question on the availability of the drivers. So there is for indoor an SR driver already available, and the outdoor driver will be available in the course of this year. So in the course of that will be Q3, Q4 this year. I hope this answers the question.
Okay, another question. How would the architecture look if the fixture includes, and I'm sorry, my screen just moved, bear with me. If the fixture includes more than one driver, plus one sensor, plus one CMS node?
Okay, so I will take this question. As most of you know, DALI is a bus system, so in this case it would be no problem to hook up multiple nodes to the same DALI network. As also described in the DALI 2.0 specification.
Okay. Next question. Can you give more details on the LSI pin?
This pin is ensuring backwards compatibility, especially for the US market, where we also take into account the sensor input. This is typically not used in Europe, but it's targeting the US market. I hope this answers the question.
Okay, that seems to be all the questions we have at the moment. As I mentioned earlier, when we send around the email, we will include the contact information for the presenters, and you're free to ask them any specific questions you have. We'd also very much like you to complete the questionnaire to give us your feedback on today's webinar and on the specification proposal itself. So with that, thank you very much for attending, and goodbye.